Greetings.
Hi.
We're all good.
Hello.
We're all good. We're all good. Yes, we are live. Excellent. Had a bit of a glitch before.
We are live indeed. Good evening, everyone. Hey, Nick and Terry. How's it going?
Good to be back. Awesome. Good to see you again. Now, the reason we're all so relieved to be live and breathing and seeing each other's faces, talking in tandem with our visuals and audios, is because we were facing some technical glitches just before going live, and I think we've managed to overcome everything to start the show for you guys tonight. Welcome back again to the Space Roundup, and if you're new here, this is where we bring you the latest and greatest of space news from across the universe with our very own space experts and astronomers, Nick, Howes and Terry Moseley. Now, without further ado, I'll hand over to you guys for another cracking show. Remember, please also tune in with our interactive YouTube comments or Facebook comments, wherever you're joining us, and ask questions if you have any. Have fun, guys.
Cool. Cheers, Latch. Good to have you back, Terry.
Yeah, likewise.
Yeah, it's you've got a nice tan as well, so you've obviously had a great time down in Australia.
Yep.
For those of you with us last month, when the fantastic Stephen Ringler stepped into Terry's not insignificant shoes, head of Space Store. Yeah, we miss you, Terry, but we are so glad you're back and so glad you had such a fantastic time. And from what I can gather, saw the eclipse in all of its glory because you had pretty much blue skies wall to wall.
Yeah, absolutely. I think everybody that was in Western Australia in the track of totality saw it, which is pretty good. But actually, it only just touched the landmass of Australia, although half of the continent would have seen a partial eclipse. But you really have to see the total part of it. And we did. We had a fantastic time and a lovely holiday in Australia while we were there.
It's really interesting. I've got a friend I used to work with when I was in the music industry, and she's got an office now, and her office was right under the path of totality, and her office is basically on a beach in Western Australia. So, Sue, if you ever get to listen to this, there you go. Hi, Sue. A lot's been going on while you've been away, Terry, and you've been catching up on a lot of it. I know that. We've had some pretty big events. As I said, we've had some technical issues, although our technical issues, unlike some of the ones down in Cornwall, don't end up almost killing people, as I've just recently tweeted. But we've had some big bangs elsewhere in the universe, haven't we, Terry?
Yeah, indeed. Always something happening.
So M101.
Yep.
I've not got to see it with my own eyes yet. I was over at Marlborough College, which is a school not too far from where I live, a few days ago, and they have quite a large telescope. I know they've been imaging it regularly. Do you want to tell us all about this amazing supernova?
Yes, indeed. If you thought the days of amateurs discovering bright supernovae or indeed comets and so on are over, think again. This one was discovered by a Japanese amateur astronomer ahead of all the automated supernova search programs. So it just shows you it can be done. It's an M101, better known as the Pinwheel Galaxy, a beautiful face-on spiral galaxy in Ursa Major, one of the best-known Messier objects. And you can see the galaxy itself with a good pair of binoculars. You probably need a decent telescope to see the supernova itself. We'll talk about that later. But this is officially called SN for Supernova 2023 IXF 2023 for the year, IXF being the designation for the order in which it was found, given the halves of the months, basically from January. So discovered by Japanese amateur Kyoichi Itakaki, I hope I've got that right, in Japan on the 19th of May. And then confirmed, because it always takes a follow-up observation to make sure that it's genuine, the next day by the famous Vicky Transient Facility in California. It was in the news recently because it discovered quite a bright comet. It's one of those automated search programs that I'm talking about. But as I say, this Japanese gentleman beat them to it. Now, it has reached just above 11th magnitude. I think it was below 12th magnitude when it was discovered, so he got it before it peaked. And this is the closest supernova to Earth for a decade. It's in a galaxy which is relatively close to us, 21 million light years away. And that's on our doorstep in terms of the cosmos. So this is a type 2 supernova. That's when a red supergiant, a star like Antares or Betelgeuse, which is about the size of the orbit of Mars, so absolutely huge, hence the name supergiant, reaches a certain stage in its evolution and goes bang. Now, to try and put a little bit more detail into that, all stars basically start off burning mainly hydrogen into helium, whether they're small stars, medium stars, or big ones. Big ones go through their process much more rapidly because they're much more massive. The pressure of the gravity of the sheer weight of the material in the star is squeezing down much harder than for other stars on the core, and that makes all the nuclear reactions happen more quickly. So stars like this one, or like Betelgeuse or Antares, go through their lives relatively quickly, a lifetime of maybe a few million years. They live fast, die young, as they say, like rock stars. And all stars, as I said, start off by burning hydrogen, fusing it into helium, and then they work their way up the periodic table. Not going to go into all the details, but they create successively heavier and heavier elements until they reach the stage where they're producing iron. And then the process changes, because to produce iron, you have to put in more energy than is given out by the nuclear reactions. So the star basically runs out of an energy source. It can still produce iron, but it takes more energy from the reactions than it gets back from the fusion. That means basically that there's no longer any outward radiation pressure to support the huge weight of the outer parts of the star. And that's what basically keeps the star in its normal size. For example, the average density of the sun is not as high as that of the Earth, because most of it is a bloated plasma. Now, not call it an atmosphere, but gaseous in terms of plasma. So that's what keeps a star like Betelgeuse, or this one that went supernova, as big as it was. When that radiation pressure is cut off, all that mass collapses down under gravity very, very quickly, accelerating faster and faster until it hits the core. And then there is an absolutely enormous bang, a shock wave, a rebound, and that causes the supernova, which is basically that star blowing off all of its outer layers in an absolutely stupendous explosion. And that's what happened with this one. Interestingly enough, that is a galaxy that was being studied very intensively and imaged in very great detail by JWST. But they found almost immediately the supernovas, the precursor, the original star, by going back through images. So they have a lot of detail on the star that actually went bang. So what happens then is that all this material is blown off into space, highly energized and shining very brightly. As it expands and the surface area that we see gets bigger, the star brightens until it reaches maximum. And then the various nuclear reactions that are still going on in the decay of the material, mainly iron decaying to nickel and so on, the brightness gradually drops off. So it's just still round about maximum brightness, or maybe just slightly below maximum brightness, and visible in a good big telescope with your eye if you know where to look, and certainly easy to image for people that are used to doing deep sky imaging, and maybe Nick will say a bit more about that. So this is not the type of supernova that we use for the distance measurements that you have heard us talk about many, many times in terms of measuring the expansion rate of the universe. They're type 1a, caused by a different process. These ones just aren't quite as bright in terms of the total brightness, but even so, that star, which was already very bright, would be tens of thousands of times brighter than the sun, increases in brightness again by a factor of about another 10,000, 5,000 to 10,000 times brighter. So in some galaxies, the supernova actually, when it appears, is as bright as all the other stars in the galaxy put together. Now, this one is relatively close to us, but still it's in a different galaxy, so it's going to cause absolutely no effects here on Earth. If there was one in our galaxy which was relatively close to us, then it could have such effects, but it's just an amazing spectacle. It's close enough for almost any decent telescope to get images, and a lot of the telescopes all around the world are busy studying that with all the different means at their disposal. So, as I say, it's the brightest one for a decade. It is visible in a good telescope in your backyard if you know where to look, and certainly easy to image, possibly even now with a smartphone held up to a decent sized telescope. Nick, I'm sure you want to say a bit more about that.
No, it's very interesting. It's apparently around about visual magnitude about 10.6 at the moment, according to some of the measurements I've seen lately, which, as you said, Terry, is well within reach of most backyard telescopes. I mean, something like a 6-inch Newtonian, for example, which is a quite a common telescope, or a Dobsonian, which a lot of people I know who do watch the show and listen to the show have got. Very, very capable instrument in terms of being able to visually spot it. Obviously, naked eye, it's not ever going to get anywhere near naked eye visibility, but it's really easy to find as well. The beautiful thing about M101 is it's just right in off the constellation of Ursa Major. I mean, it's really easy to find, just kind of following the track of Ursa Major around. It's really interesting. A friend of mine was imaging Messier 51, which is another kind of face-on spiral galaxy, beautiful structure as well. The night that this supernova kicked off, it was about 5 or 6 hours later, and we got the ATEL, the Astronomers telegram, saying that a new supernova had been discovered. And I said, well, you need to move your telescope just a little bit that way, kind of, because it was looking really good. What's also interesting about this, you touched on it, it's a Type 2 supernova. And we've had a lot of interest, and we'll probably cover this a bit more in future shows, on Betelgeuse of late. And there's still more happening with Betelgeuse. There's this weird kind of brightness variance. What's going to happen with Betelgeuse, again, is it's going to go at some point. It could be next week, it could be tomorrow, it could be in a million years' time, we don't know. But it is going to basically be a Type 2 supernova. You've got, again, a supermassive star that is essentially just going to go pop at some point, run out of fuel and collapse, as it were. What was interesting about this, even though it was initially detected by an amateur observer, the Spitzer Sky Survey, which is one of the big infrared telescope surveys, just adjusting my microphone, one of the big infrared telescope surveys, they had images of it basically when it was around about magnitude 14.9 to 15, so a few days before it was picked up by the Japanese amateur, which I find really interesting. As you said, it shows you that amateur observers can still detect new comets, can definitely still detect new asteroids, even though we've got all these automated sky surveys. It's one of the problems that the automated sky surveys are finding is becoming increasingly a problem, putting it bluntly, is the amount of space debris that's getting in the way, and the number of satellites that are basically affecting the track of these automated sky surveys, and how the data reduction systems, the automated processors, can handle this data coming in, especially for moving objects. Supernova, not so much, but you do have transient events, obviously, with satellite reflecting, satellite reflections causing significant bursts in brightness. They're normally only over a few seconds, like some of the iridium flares that we've seen for many, many years now. This one, if you go out any time, basically in the next couple of months, you should be able to see it. And with the dearth of kind of deep sky objects, as it were, during the summer months, especially in the northern hemisphere, it's going to be a good one just to target an image. If you've got even a basic spectroscope, and you can get things like the rainbow optics eyepiece, which you can just fit in front of a camera. There's an awful lot of people I know doing amateur spectroscopy on this, and again, just showing a spectral line, showing what the chemical composition is of what's coming out of this star. And it looks like the progenitor star, the precursor star, was around about 15 times solar mass. So not huge, but significant. 15 times solar mass isn't insignificant. There's already been a paper put out about it, so it's well worth searching that one up. But yeah, it's going to be a cracking object to keep an eye on, because it's easy to find. Yep. I mean, that's the nice thing. It's one of those really easy to find ones. As you said, it's one of the brightest ones in a decade. In the last 5 years, it's probably one of the closest ones as well. We are long overdue a good supernova in our own galaxy. I mean, 1987A in the Southern Hemisphere, which was kind of nearby, but kind of not, as it were. Everybody's just waiting for Betelgeuse to go pop, but as I said, that could be tomorrow, it could be a million years, we just don't know. It's well worth keeping an eye on this one. So
I was going to say, look now as soon as you can, because first of all, the moon is brightening, and secondly, we're heading towards summer solstice, when the sky is at its brightest all night. So get a look as soon as you can within the next couple of days, and the weather is fantastic at the moment.
Absolutely. So we've started off with a story about something going bang. We're going to go into another story about something that could have gone back. Well, did go bang. This is the ongoing saga of Spaceport Cornwall. Now, as you may be aware, January this year, Spaceport Cornwall, in collaboration with Virgin Orbit, were attempting to become the first European launch site to have a horizontal launch, or a space launch from a European site into orbit, and it sadly all went very, very wrong, very, very rapidly. The Cosmic Girl aircraft, a modified 747, dropped the rocket over the Atlantic in the wrong place, it now transpires. It had an issue with part of its onboard propellant systems and its combustion chambers, etc., and various things kind of dislodged, causing it to fail and then basically crash land just off the Canary Islands. What's interesting about this is now further studies by a company called Newton Launch Systems, and they conducted a study. They basically, and they're not the only ones. I know this for a fact because I was involved in some of the early discussions with Spaceport Cornwall. We all had concerns about the range safety and about the fuel and gas and explosive safety of the whole system, because you've got a commercial airport. Newquay Airport is a commercial airport, and you had an awful lot of people basically right up close on the runway, very, very close to the launch vehicle, as it were, the modified 747, which basically had, in essence, a bomb underneath its wing. It had a big rocket that was full of propellant that could have gone pop at any point, but thankfully didn't on the runway. But they've raised concerns now, and they basically definitively proved that had it exploded on the runway, then people would have died. You can't really cut it in any other way. People would have died. The explosive, force of that, plus the amount of fuel and propellant, etc., and the debris. You only have to have a look at what happened with Boca Chica, with Starship, obviously a significantly larger launch system, but you look at what happened to most of that area. It turned into a crater and the debris was flying off and trashing cars, several hundred meters away. So as I said, my company got involved in some of the negotiations with Spaceport Cornwall and Virgin Orbit around about 3 or 4 years ago. Our company do a lot of work with fuel and gas safety and ordnance and munitions and explosive safety for the defence organisations around the UK and around the world, etc. And we'd expressed concerns about this. What was also then interesting on top of this is that initially the report said that the CAA, the Civil Aviation Authority, their oversight on this was considered to be too onerous, too extreme. It transpires that this isn't the case. It wasn't strong enough, according to the people, as I said, from Newton Launch Systems, who've come to the conclusion that not enough was done about the range safety and the localized explosive safety, etc. Now, given that there's multiple agencies involved in these launches, you've got the Maritime and Coast Guard Agency, you've got the Civil Aviation Authority, you've got various environment agencies, etc., to make sure that things are all safe. And you've got this not only happening at Cornwall, but you've got these happening across all of the launch sites in Scotland. Putting an awful lot of people near to a launch is never a good idea. You only have to look at the Saturn V. People are kept several miles away from the launch. Starship, people are kept several miles away from the launch. Even the smaller rockets, like the smaller Falcons or Peter Beck at Rocket Labs down in New Zealand, people are kept well away from the launch site. And this should apply as much to vertical launch as it does to horizontal launch. So, and when I said it was launched from the wrong place, this goes then to the range safety. And one of the things I know we talked about with them was the range safety issues, in that you've got a moving launch platform. You've not got a static launch platform where you can effectively calculate where the rocket nominally will go. And if there's a failure along that orbital trajectory track, that kind of going up into orbit, in the case of some of the Scottish sites, you're going over the Faroe Islands, etc., then you kind of know where things could go wrong and you plan ahead for it. With Virgin Orbit, they had a moving platform that even a very small change in the vector or change in direction, change in wind speed, etc., could have affected, and in effect did affect, where this thing went wrong. Because in effect, I mean, there were videos showing this, it landed just off the Canary Islands, and it could have been far worse. It could have actually hit part of the Canary Islands. Now, given that some of the payload on the spacecraft, on the rocket itself, were very, very highly secretive military and defense payloads, that's not really a good thing. It was a close call. It was launched from the wrong place. It's now resulted in the head of Spaceport Cornwall, Virgin Orbit's, collaborative partner. Virgin Orbit obviously are no more. They've completely gone. Their assets have been stripped and sold. I mean, I think Cosmic Girl went for about £17 million or dollars. So everything's gone. Virgin Orbit are no more. They've wound. They've gone. But even Melissa Thorpe, now Melissa Quinn, at Spaceport Cornwall, has resigned on the back of possibly this report that was going to come out that raised all of these concerns. What this then gives us kind of food for thought is what's happening up in Scotland. And again, you've got significant range safety and environmental issues, which I know a lot of the Scottish launch sites have worked on and are working towards, but it kind of shows you that you really need to tick every box multiple times and get it really, really, really right. Because when things go wrong, in this case, thankfully, nobody was injured. Nobody was hurt. The only thing that was really hurt was Virgin Orbit's capitalization and market share and pride of many people, but effectively, and obviously the loss of multiple satellites, small satellites on the launch vehicle. But you really do need to do it properly. You can't do space on the cheap. That's the fact. That's the reality of this. And trying to cut corners wherever that may be, if it's in the integration and testing, if it's range safety, if it's the launch safety, if it's propellant, you've got to get it right, because when you don't, things, you never recover. I mean, SpaceX, they kind of blow things up on a regular basis, and people, there's almost like a cult following of people going, yeah, it's just SpaceX is what they, and it is true. I mean, they've put a lot of time and a lot of energy and a lot of investment into what they're doing, and they've had incredible success. You only have to look at the Starship failed launch, and now the Federal Aviation Authority and the Federal Communications Commission and various other people are now intently looking at them, because the environmental impact of what they did at Boca Chica was quite significant. And everybody's now taking a lot of attention to launch, whether it be gigantic rockets launching from Texas or smaller rockets launching from UK soil. What's also interesting, however, is that tomorrow morning, this UK government stance of we're going to be the first to launch a spacecraft into orbit from European soil may be gone, because there's a Spanish launch company who are launching out of Huelva on the west coast of Spain who may beat them to it, and that's their coverage for that starts at about 5:30 CET tomorrow, runs through till about 10 o'clock. So if you're up tomorrow morning, tune in on YouTube and you may get to see the first launch from European soil of a rocket into space. I don't know what your thoughts are, Terry, on this, but
Yeah, I agree. I mean, the whole idea of Cornwall to me always was slightly dicey, because it's there are areas up in the Moors, for example, which are not too populated, but all the seaside resorts, they have a constant population and boosted considerably during the summer. Whereas up in northern Scotland, you can certainly have a lot more freedom to have a launch without having to move too many people out of the way. But in a way, there's one good thing that has come out of this, and that is that Rocket Lab has managed to get a lot of the Virgin Orbit assets at a knockdown price, and that'll boost their chances. They're working on a new, larger rocket, the Neutron. And they've got basically a lot of stuff for about 1% of its valuation. So that'll give them a boost. I'm sorry for Branson and Virgin and so on. By the way, it doesn't affect Virgin Galactic, who is a different branch of the organization, where they're hoping to take very soon, actually, the first paying customers up to the edge of space. And no doubt we'll cover that when that happens. But yeah, one man's misfortune is somebody else's luck. And in this case, it's Rocket Lab that has benefited out of this. Sorry to see it happen, but still hope that we can get a launch from UK soil sometime before too long.
But again, with Virgin Galactic, yes, they are continuing, but they've had issues. Obviously, the fatal crash a few years ago with one of the test pilots, the co-pilot, sadly passing away. And even the flight with Branson on went wrong. They went out of their nominated range. They had, they breached like some of the air regulation safety concerns, as it were, or they kind of did a bit of a naughty and then tried to kind of cover it up. So it's worrying me, this one. Initially, when I first saw the Virgin Orbit thing, yes, same concerns as you, Terry. I mean, nobody wants to kill the Fisherman's Friends, for example. You got a fantastic Close Harmony folk choir down in the Cornish Port Isaac. You don't want anything to happen. But that's the thing, as you said, Terry, it's a really popular tourist destination. Obviously, a lot of people live down there as well. It's not, up in the Highlands of Shetland at Saxford or wherever, where different issues aside, they've only got to really concern themselves mostly with the puffin population or the bird population up there. They haven't really got to concern themselves with an awful lot of people. They've got issues with various other sites with peat bogs and the flammability of peat. But it's going to be an interesting one to watch. And again, if Spain are able to beat the UK in terms of getting something into orbit first and successfully, again, what's that going to do to the market? Because with Spain, with a Huelva launch, you're very close to, much closer to the equator. So being able to do equatorial launches from Huelva, which is what they're able to do, which you cannot do from Scotland. Well, you could, but the amount of energy required would be enormous, and it's just not commercially viable. The Scottish launch sites are all going for, apart from Prestwick, which is adopting a very similar model to Spaceport Cornwall, in that they're going for a horizontal launch from a commercial airport. And again, Prestwick, this is not Newquay isn't a particularly crowded or very, very busy airport. Prestwick is far busier, and you're going over, again, lots of Scotland to get into your launch site. So there's a lot of things that need to be thought through here, rather than chasing this dream of being, the first and the biggest and the best, and all of these other huge government aspirations that kind of fell apart post Brexit. Just do it right. That's the fundamental thing. And if you don't do it right, then you've got to be someone like Elon Musk, who's quite happily spent, I read today, $5 billion so far on Starship. Now, compared to Artemis, it's not in the same league. Artemis has gone way over budget. It's in like probably 2 to 4 times that amount. And he potentially is going to succeed, maybe not on the next launch, but within the next year or so, he will probably succeed, because you look at the trajectory of the Falcon 9, Falcon Heavy, etc. They've done it, and Falcon Heavy did it the first time. So he's the one to watch. And the other thing is that the launch costs. Now, SpaceX are one of the trajectory analysis reports I saw in terms of their costings. They're looking at something like $180 per kilogram to orbit. Once Starship becomes regular, its cadence becomes quite regular. That is unheard of. I mean, being able to launch a CubeSat, a 1 kilogram CubeSat to orbit for effectively under $200, which is what one of the reports stated, is just astonishing. I mean, if you've got 140 tons launch capability to low Earth orbit on Starship, you can pack an awful lot of CubeSats at 1 kilogram into that. So we shall see where this heads. But yes, it's very interesting. However, not quite as interesting as our next story, which we're going to go further out into the solar system.
Yeah.
And
just before we go on, a couple of questions there. A good friend of mine, Mike Foylan here, who has imaged the supernova. Interesting about Betelgeuse. The latest information is that they think that the massive expulsion of dust and gas that happened that made Betelgeuse dim about a year ago, I suppose it is roughly now, that has upset sort of the rhythm of the star. It is variable with an approximately 400-day cycle. They think that cycle has now been at least temporarily disrupted. It's now on a much shorter cycle of variation, perhaps 50 days. I've heard 200 days, but it is actually brightening, and it's much brighter than normal at the moment. Now, that in itself is not an indication of an imminent supernova explosion. It just shows that things are happening in these stars that we still don't entirely understand. So it's always worth keeping an eye on any of these big bright stars like Betelgeuse or Antares. Betelgeuse we can't really see at the moment. Antares is coming up to its best in the summer. So yeah, to go on to the next story, our new best friend, James Webb Space Telescope, in the news again. When has it ever not been for astronomers anyway? It has imaged now a giant gazer on Enceladus, one of Saturn's moons. Fascinating moon, one of the icy moons of the icer planets. Now, what happened was, we know that Enceladus does every so often have plumes of gas and embedded materials, shall we say, in the plumes that were imaged as far back as the Cassini mission. But with JWST, the power, we don't now need to have a spacecraft actually out at Saturn. It imaged a really huge plume or jet being emitted from Enceladus. It actually happened last November, but the paper describing it has only just been released at the latest STSI conference. So these things are fascinating. As I say, this is an icy moon. It is so far out from the sun that basically you'd expect the temperature to be several hundred degrees below zero, and it's round about that. So how can there be liquid water? The moon is covered with an icy crust, maybe 20, 30, perhaps up to 40 miles thick, although Enceladus itself is only about 300 miles in diameter. But if you saw the photographs that were taken by Cassini, it is covered with what are called tiger stripes. And these are cracks in the surface. And the coloration that goes along these stripes indicates that material, almost certainly organic material, is welling up through these cracks in the ice from a liquid ocean below. And you may well ask, well, how on earth can there be any liquid water and something so far from the sun? And that all comes back to gravity. basically the tremendous gravitational pull from Saturn as it orbits, as Enceladus orbits around Saturn, alternately squeezes and squashes the moon very, very slightly. But the orbit isn't perfectly circular, slightly elliptical. And that squeezing is the way you get it. If you squeeze a rubber ball backwards and forwards in your hand, it heats up. That causes heat inside Enceladus, and that we think that is what causes liquid ocean. The fascinating thing is that there are organic materials in this water that is being injected through the plumes. And when there's water and when there's organic material, there is the possibility of life. In fact, methane is one of the gases that has been detected emitted from these plumes. And there's some speculation that the methane is actually not just endemic to Enceladus, that the methane is actually being produced by organisms in that liquid ocean. And that's a bit of a leap of optimism, I think, but it's certainly a possibility. So good old JWST has imaged this amazing plume, which is actually shot out into space more than twice the diameter of Enceladus itself, much bigger than the plumes that were imaged by Cassini. So there are all sorts of plans now to send some sort of a spacecraft out to Enceladus, perhaps also via Europa, one of the moons of Jupiter, which also emits these plumes of material from a liquid ocean beneath a gaseous, or beneath an icy top. And there are a couple of options. One is one they call the Orbi lander, which will orbit around the moon for a while and then land on the surface. The most fascinating one is what they call the snake, which would actually burrow down through the ice somehow, right down into the liquid ocean below and see what's there. There are no easy ways to actually do that, especially as it's so far away. But Nick, I'm sure you've thoughts on what would be the best way to explore this amazing phenomenon further.
Well, it's interesting because obviously it is pretty close to your heart, I would imagine, Terry, because you've got Michelle Doherty, who very, very famous Irish astronomer, who was the PI for the magnetometer instrument on the Cassini spacecraft, and they were one of the first people to really make this detection. Obviously, Dr. Calvin Porco, etc., and your imaging team there did a huge amount of work on this as well, and there's a lot of credit to be kind of evenly spread amongst the various teams that were involved in this initial detection of these geysers on Enceladus. What we need obviously now is more instrumentation, like basically on orbit, to look at what the water, constituents on the water, and to obviously look for the potential for organic material coming out from Enceladus from these geysers. Because obviously you've got a shielded, like Europa around the Jovian system, you've got a shielded moon with thick ice crust that's clearly got liquid water beneath the surface. Now, we've proved with hydrothermal vents and some of the deep ocean surveys on here on Earth that you don't need sunlight, you don't need certain things that we would consider to be normal for life to exist. So that's one thing I'd love to see. The JWST, the really interesting thing about this and the work that's going on here is this is Dr. Heidi Hammel. Now, Heidi Hammel, I met years ago at the NEAF conference in New York, Suffern, just north of New York, the Northeast Astronomy Festival. And she was giving a talk, this is going back to about 2010, about the whole James Webb Space Telescope potentially being cancelled. And this got picked up by a journalist who sadly now passed away, Paul Sutherland. I came back home, basically talked to Paul and said that, have you heard about this? And it basically then went into the national news that there was a plan by Congress to cancel JWST. So it's almost come full circle in that Heidi Hammel has, started the fire under so many people's kind of bellies, as it were, to get the James Webb successfully launched. And now some of the data, and it's just a mountain of data that's coming back from it. We thought Hubble was significant. James Webb is just delivering constantly. And you look at the images from the JWST of what they're seeing with these like almost Earth-sized geysers of water coming off the side of this tiny little moon orbiting Saturn. As I said, I'd like to see more missions back there, and I know Calvin Porco, who's a dear friend, and you know her as well, Terry, and she's visited Ireland. I know she was at Dublin a few years ago. I know she's very, very interested in pushing for this and a return to Saturn, as it were, because whilst Cassini-Huygens mission was incredibly successful and did phenomenal work, the instrumentation that they need to do this more investigative work just wasn't there. It wasn't on the Cassini spacecraft, wasn't on Huygens, only lasted for a few hours, obviously, once it's touched down on Titan. There's so much in the Saturnian system that still needs to be investigated. So I think, yeah, this is a great kind of discovery, as it were, and you only have to look at what's coming from Juno with Io and the recent images of that as well. You know, deep space planetary exploration is what we are incredibly good at, and instead of polluting low Earth orbit, that's what we need to be doing, is more like that. I'm looking through the questions as well. Somebody asking, Christian asking about the EM spectrum bands. So this is an interesting one for Type 1a supernova. This has only recently been done, and you'd think, well, radio telescopes have got these huge, great big dishes, they'd be able to pick up supernova, no problem. The first radio detection of a Type 1a supernova, which is not the same type, obviously, has been detected in Messier 101, which is Type 2, but Type 1a, which is basically when a larger star's dragging mass of another star, and then it kind of grows and grows and then goes pop. That was only in 2020 using the E-Merlin network up at Jodrell Bank. Now, some years ago, I was involved for a few years in the Square Kilometre Array telescope, and that's going to be the game changer in terms of, you know, Southern Hemisphere anyway, in terms of all sky detection capability, all sky survey capability, and the resolution, which is going to exceed the Hubble by 50 times in the radio frequency band, which is quite incredible, and being able to sample across thousands of different frequency bands at the same time. And they've got what's called phased array telescopes, where they can basically use a single flat panel telescope dish to point at multiple regions of the sky at the same time, or they can direct all of the focal energy, the focus energy of that, to a specific region. So it's a really good question as to what bands. This is the problem, again, relating back to space debris. Some of the bands like band 5b, which is quite an important radio astronomy band, is now dead. Because of the amount of gumph that's going up in low Earth orbit. And the problem you've got with many radio telescopes is they're having to filter out so much now. They're having to filter out, obviously, what's terrestrial, what's around them, you know, a car engine turning on, somebody using a cell phone, etc. Anywhere near any of these big sites. And it's a problem that they have to filter out. They have to use, you know, some of the most powerful computers in the world. In the case of the SKA, it will be one of the most powerful computers in the world to do not only the filtering and the data reduction, but then to work out what is actually a worthwhile signal. And it's not just that it'll be able to pick up supernova, it's going to be able to pick up so much as a radio telescope. So in terms of what bands, you'd have to look at some of the research papers as what specific frequency bands are used and are most optimal. Obviously, they're looking in hydrogen bands. So if you've got significant events in those kind of frequency ranges, then that's probably where you're going to pick up some of this. But it's going to be really interesting, as I said, to watch not only the Square Kilometre Array, but obviously the big Chinese half-kilometre wide radio telescope. A lot of science being done there. Not a lot of it's coming out of China, unfortunately. But the beauty of interferometry and the beauty of radio telescopes, and you can do it with optical telescopes, it's been done. It's far more complex, but with radio telescopes, being able to basically turn the entirety of the Earth into just one great big radio telescope, where you've got telescopes on one side, telescopes on the other, and they basically combine their signals to give you a much wider kind of telescope field of view. If you combine that with something like the Square Kilometre Array, which is thousands of telescopes across Murchison in Australia, and then thousands of telescopes across the Karoo region of South Africa, working in different frequency bands, complementing each other, so low frequency in Australia, mid and high frequencies in South Africa, it's going to be as much of a game changer, I think. I don't know if you agree, Terry, as the James Webb has been to optical infrared, infrared in particular, obviously observations from deep space. I think the SKA, hopefully, if nothing gets in the way, as in space debris, is going to be as big a game changer. I don't know.
Absolutely, yeah. I'm not sure exactly how to interpret that question. I wasn't sure if it was just radio telescopes that Christian was talking about. In fact, a supernova emits radiation the whole way across the spectrum, from gamma rays through X-rays, through UV into visible light, microwave, and then into the radio end. And what we can observe from Earth simply depends on which of the wavelengths are transparent, come through our Earth's atmosphere. Apart from that, you have to be up into space. But yeah, basically, this thing emits radiation the whole way across the spectrum. Another question there from Mike about the UAE mission to the asteroid belt just announced. Yeah, they're planning to send a spacecraft out to study about 6 different asteroids, looking in particular for materials which could be the precursor to life. And we may say more about that later, but just a quick answer on that one.
Yeah, and the UAE again, much like what India have done, Israel, the Indian Space Agency, in terms of getting an orbiter to Mars first go. UAE the same, incredibly successful, and it proves that I was saying before that you don't do things on the cheap. You can do it cost effectively. It's just you've got to be really diligent about everything that you're doing, systems integration, your systems engineering, etc. You've really got to be on the case, and it looks like in the case of Israel and the UAE, they've done a remarkable job. It sadly brings us on to our kind of final story, which is something that again didn't quite go right. So Hakuto R, which is the Japanese kind of private space mission. So JAXA are the big Japanese space agency, and decades of phenomenal success. They've had astronaut launches, obviously to the ISS from their partner organizations, etc. But JAXA themselves, from their own launch sites, have done significant work in terms of deep space missions to asteroid sample returns, etc. Now, what seems to be happening more and more, and we've seen it obviously with the likes of SpaceX, is commercial space companies and amateur organizations, universities, etc., are getting more and more proficient because the launch costs are coming down, because the technology is becoming a lot more inexpensive, for want of a better term, and what's called COTS, common off-the-shelf technologies, are becoming more and more prevalent in these areas. I mean, you can literally go to a satellite shop in Scotland on the internet and buy your own satellite. I mean, I've got a small Pico satellite from a company called Ambersat, which was a few $100s. I mean, you can literally get something into orbit now for under £1,000, about $1,500, $1,200, $1,500 easily. If you wanted something, a micro satellite or a CubeSat, a few tens of thousands of dollars now, realistically. So like we had with the Google X Prize, and Ansari X Prize, where we had the first, orbital missions, where again Virgin Galactic being, the first to kind of touch the edge of space, as it were. And you've got people like Jeff Bezos doing these suborbital hops, in a Mercury mission style capsule. Fantastic. People are setting their sights a bit further now, and we've seen CubeSats going out as far as Mars. Some of the support systems for some of the recent Mars missions have been CubeSat based, or 12U, not much bigger than a 1-unit cube. Hakuto R was this independent private mission by a Japanese consortium, some European involvement as well, to try and become the first to successfully land on the lunar surface. Now, the only 3 nations who've managed to do this so far successfully have been obviously the Americans, the Russians, and the Chinese. Chinese have done it very successfully. They've got rovers on the surface, orbiters out as far as it can go, taking phenomenal images and acting as relay stations for their systems, which are on the far side, as it were, of the moon. But no commercial entity has yet managed to do it. There have been several attempts. The Bereshit lander, which was an Israeli kind of consortia, non-profit, Space IL, they launched the moon 2019. That sadly crashed. There were all sorts of issues with that came out in the kind of post-mortem. Then the Indian Space Research Organization themselves, they tried to land a rover at a lunar spacecraft, I think it was, the same year, the Vikram. That failed as well. What seems to be a common thread here is running out of fuel and issues with the range detection and the landing systems. So funnily, Draper Labs. Now, Draper Labs may not be a familiar name to everybody, but Draper were involved in Apollo. They were the first people. The Apollo guidance computer was the first contract that was actually awarded on the Apollo program, because NASA realized that the landing computer systems, and if you think back to the early 1960s, a 1 kilobyte, 1 megahertz computer would have taken up something about the size of a basketball court in terms of physical space. They had to get that down to something that essentially was about the size of a small suitcase, or a medium-sized suitcase, as the main Apollo guidance computer itself, and then a user interface which had to do multitasking and all sorts of things, interpreting multiple data feeds. And they had to do that within Kennedy's timeframe. So from the early 1960s up to 1969, we saw some of the greatest developments in computational systems ever. What it looks like the Japanese are now saying is that there was an issue with their landing system, again developed by Draper Labs, where it basically passed over a crater, and initially they were aiming at a different region for landing, a much flatter region on the moon. They ended up going for the Atlas crater because they thought it'd be more interesting. What seems to have happened is that as they were traversing over some of the rims of the craters, there was a mismatch between what the landing radar system and some of the software systems were saying, and the software system decided to override what was in fact accurate data. Therefore, they managed to decelerate down to a nominal speed around about 2 miles an hour. They were ready for landing, but essentially the spacecraft shut everything off, and it just then crashed into the lunar surface at around about 200 miles an hour and smashed all over the place. But they also ran out of fuel. So there's two lessons there. Is one, test your software better, and that's the beauty of this system, as it were, that they know that they didn't really get anything wrong in terms of the physical hardware. A bit more gas, and that goes back to Apollo 11 as well. They almost ran out of fuel with the Apollo 11 landing, and they had the 1201, 1202 alarm issues with Apollo landing as well, again due to mismatches and too much data coming in on the landing radar into the Apollo guidance computer, and errors, warnings being thrown up, etc. So it's kind of, make sure that you've got enough gas in the tank, but make sure that you really thoroughly test your software, because if you make a change, and this was probably their downfall, they made this relatively late stage change in the mission profile to go for a more interesting crater. And effectively, the engine, the altimeter, and the other hardware systems were all saying, yeah, this is all good, this is all fine. And then the software system said, no, it's not right, it's not working. So again, it goes back to what we were saying before about Spaceport Cornwall. If you're going to do it, you've got to do it right. You've got to do it thoroughly. You've got to test correctly. I mean, test engineering is such an important discipline. I'd say that because that's what I do. I'm a test engineer. But it really is a critical part of the whole life cycle of any system that you build, be it a weapon system, be it a computer, whatever you build, you've got to get it right, and you've got to test it. And you don't let the people who build it test it, because it's called in the industry dog fooding. You basically don't eat your own dog food. So essentially, you get a good test team in, and you make sure that they really thrash the systems, to the nth degree, to make sure that everything is right. It's such a shame, though, because they came so close, Terry. I don't know what your thoughts are.
So the whole point of the story is that the Lunar Reconnaissance Orbiter has actually imaged the bits of debris on the surface. But it just makes you think, if that had been a crewed mission, and they didn't have manual override, or if it was a case of running out of fuel, that's casualties on the moon. You really cannot afford to get it wrong. Something has just occurred to me, actually, going back to the previous story. The JUICE mission, which also was a story that we could have covered. JUICE stands for Jupiter's Icy Moons Explorer, and it's on its way out, actually, to explore the moons of Jupiter. It had a problem with the antenna that wouldn't unfold, and they basically managed to give the thing a good jolt and shook it out. But that's another mission that is going out to explore this fascinating area of the outer icy moons, which have liquid oceans below an icy surface. But yeah, I totally agree with what you're saying about getting it right, particularly, as I say, when we're coming up to manned missions or crewed missions, I suppose is the way. I have amazing worries about trying to land up near the lunar South Pole where the craters are in shadow. It is not going to be easy. You have radar, but there will be areas below that spacecraft where they won't be able to see anything. If they're coming from the daylight side heading towards the night side, they're flying straight into a low altitude sun. If they're going in the opposite direction, they'll be going from the night side to the dark side, so they'll have absolutely no visual cues underneath them. They'll have radar. Or are they going to fly along the terminator, the north-south line, in which case they're coming in at maybe not the best angle. If they overshoot, they go around the far side of the moon. That is going to be fascinating to watch. And as we've been saying all along, you have to get it right, particularly when there are people on board.
But that's the thing. You look at Apollo, and apart from Apollo 13, all of the missions were a phenomenal success, and they all had problems in different areas. The landing problems with 14 and 16. 11 obviously had the 1201, 1202. 13 not only had an engine cut off launching, going into orbit, but obviously a catastrophic explosion on the spacecraft itself. They were built and engineered to such a high level of precision, and given the whole argument of 6 million different parts, you only had to they had to make sure that it was 99.8% accurate, that even one thing failed, and it was a very simple failure on Apollo 13 that caused the explosion on the tanks. It is going to be interesting. It's also interesting what you're saying about the JUICE mission, and that's not the first time that an antenna has failed to unfurl, and they had to change all sorts of issues of, with Doppler shift frequencies and antenna telemetry and data coming back. And remember, on Cassini and Huygens obviously had an antenna issue on its descent down to the surface of Titan. So, and this is the problem when you launch a spacecraft, the stresses and tolerances they're just beyond anything you could possibly imagine. You have to look at the Boca Chica, go back to SpaceX again, and Chris Parr's raised a really good point in the chat there. Big advantage being able to be hardware rich and mission rich. Yes, this agile development cycle that SpaceX seems to kind of be standing by, fail fast and often, just keep iterating, they make mistakes, fix it, eventually you'll get it right, and the budget to do that, and there's a lot of money come from the US government, etc. You can, but if you think about a typical launch system, if you've even got a basic CubeSat, that's got to undergo enormous stresses on the launch, where you've got huge amounts of vibration coming from the launch vehicle. You've got vast amounts of acoustic pressure coming in, so they have to put them in acoustic test chambers. Then you've got the whole thermal cycling. Then you've got the radiation issues. And then you've got micrometeorite impacts. You've got, even on the launch site now, obviously what happened at Boca Chica is a classic example of that. You've got debris from the launch site, which can get sucked up into your thrusters and your engines and wreak havoc there. And then obviously once we're in orbit, and if you've got a low Earth orbit mission, you've got all sorts of issues now with various nefarious space actors, as it were, planning to do things like putting micro explosives into thrusters and all sorts of nasty stuff going on in low Earth orbit. That enough said about that, the better. That it's in the public domain, so it's not confidential. But there's all sorts going on there. It is true though, Chris, if you've got the budget, and this is the thing, NASA during the 1960s had, I think it was about 4.5% of the GDP of the United States was being poured into the Apollo program. Then you look at what the UK Space Agency have given to UK launch, and the numbers are quite trivial. And obviously they're not trying to do something as significant as the Saturn V, but the money's got to be there, the investment's got to be there, the commitment's got to be there, the team have got to be there. You've got to have the right people who really know what they're doing to make things work. And I wish Japan, the independent group, they've already got their next iteration plan. They're looking to fly hopefully within the next 12 months. Hopefully they do. Hopefully they are one of the first to land on the lunar surface, because we're going to need that. If you've got Artemis, you've got crewed missions going back to the moon, possibly within the next few years, not that long away now. They're looking at the Apollo 8 style Artemis 2 orbital mission within a few years. A few years after that, if the lander has been developed, and I wouldn't land on a SpaceX lander, to be honest, that not on the lunar surface, not after what we've seen, but there's other lander systems. They may get it right, they may change the design. It's going to be critical. It's going to be critical to have lifeboats. It's going to be critical to have some kind of backup life support system, something on the lunar surface, and the communications relay. If you're going for the southern lunar highlands, as it were, and some of these deep craters, as you said, you've got to make sure that all of your backup systems and all of your ground, data relay feeds are absolutely spot on and do not fail. Because the last thing you want, and this was the issue with Apollo 8, back in 1968 when, orbiting the moon at Christmas, had that gone wrong, they'd still be up there. They'd still be potentially orbiting the moon. And you imagine every time it's Christmas, you're looking at the moon. It would have been horrible. So nobody wants to see any more casualties. We've gone through two catastrophic shuttle incidents in the 80s and 90s. The Russians obviously had multiple failures that we only learned about at much later dates, as it were, but nobody wants to see anyone perish on orbit, or especially on the lunar surface. So get it right. It's that simple.
Right.
Anyway, I keep looking at parts. I've got three things. I'm looking at the questions on this. Yeah.
Okay, next one.
So look up. What have we got to look forward to?
The biggest explosion. How can we miss that one out?
How can we miss this one? Yeah.
Yeah. Space superlatives. I mean, it just gets more and more mind-blowing. The biggest explosion in space ever seen. First recorded by the ZTF that we mentioned earlier, but it wasn't recognized as such. So it was first actually noticed and recorded by Atlas. So it's given an Atlas designation, AT 2021 IWX. First, then officially noticed, if you like, in 2021. It's actually been going on for more than 3 years. Now, we're used to big explosions, whether they're supernova explosions or gamma ray bursts or tidal disruption events and so on. They are relatively short. periods of from minutes or up to maybe an hour. So in the case of a gamma ray burst, the long ones, supernovae can last bright. The actual event doesn't last very long, but they can stay bright for a month, and then they start to fade. Still visible after maybe 6 months or so. Tidal disruption events similar. This has been going on for more than 3 years. So it's been more than 10 times brighter than the brightest ever recorded supernova. And it's at least 3 times brighter than the brightest recorded tidal disruption event, where a star basically falls into a supermassive black hole and gets swallowed, as they like to say, or as the Americans say, what is it, chomped down or something? Chow down. Yeah. Anyway, so this has been going on at an intense rate of production of energy for 3 years. And they don't know for certain what it is. It's in a galaxy about, 8 billion light years away. So it happened when the universe was roughly, say, 6 billion years old. And what they think is happening is that a huge gas cloud, maybe as big as the Orion Nebula, which is busy forming stars at the moment, is being disrupted and dragged into a supermassive black hole. So that's not just one single object like a star. It is a absolutely huge mass of several hundred solar masses of material, possibly containing condensations like protostars, being dragged into a supernova, supermassive black hole, and that's why it's going on for so long. So this has produced more energy than we can possibly imagine. I don't have a figure, but basically it's the combined energy of multiple supernovae and multiple tidal disruption events going on. The brightest single event that was ever discovered was actually a gamma ray burst last year, and I think we talked about it at the time. Yep. But again, that only lasted for a relatively short period. This thing, as I say, has been going on for several years and is still happening. So the things that happen in the universe are mind-boggling. And what strikes me every so often is how we are sort of in the middle of the scale of things. The most massive and energetic events in the universe are trillions or quadrillions of times bigger and hotter and brighter and more intense than anything we have on the Earth. And then on the other end of the scale, down at the quantum level, a similar scale difference. We seem to be just very nicely in the middle, where we can observe these incredibly huge, massive energetic events and the absolutely amazing quantum world at the other end of the spectrum. And is it just fortuitous? Is it anthropic principle? I don't know, but we're in a unique position to study the universe.
It's astonishing as well. You look at the numbers on this, they're saying it's 100 times brighter than every single star in our galaxy combined. And the amount of energy kicking out in a few minutes is the equivalent of our sun's entire lifespan. The energy release for our sun's entire lifespan. So thankfully, yes, it is 8 billion light years away, because you really don't want anything like that anywhere near us. And we've imaged supermassive black holes in the center of our own galaxy, and there's some fantastic time-lapse videos going over many years showing stars basically orbiting nothing in the middle of our galaxy, using some of the radio and some of the other wavelength telescopes, because obviously you've got masses of dust in the way, so the optical observations aren't really good. But as you said, for 3 years this has been doing this. You know, the average gamma ray burst, as you said, Terry, lasts a few seconds. It's a great pub quiz question as well, if you ever want to be thrown out of a pub quiz, which I have been. Basically, when somebody says, what's the farthest object you can see with the naked eye? People go, oh, it's Messier 31, the Andromeda Galaxy. And you're saying, well, no, it's not. And M33, Stephen O'Meara and various other people have seen that naked eye. So M31's not the answer. It is a gamma ray burst. And one of the gamma ray bursts, I think, was picked up by some chap in South Africa a few years ago, where he was just looking up and he just happened to notice something flash in the sky. And it turned out it was a gamma ray burst, basically billions of light years away. So it's one of those things, definitely keep an eye out for. In this case, you're not going to see it, but it's just, as you said, Terry, it's mind-boggling to think of the energy output that is going on in our universe. And we only have to think, thankfully we only have Betelgeuse and a few other stars reasonably nearby. There's a black hole at around about 1,500 light years away from the Earth that's been detected. We don't have anything majorly threatening in terms of energy release that near us, thankfully. I mean, when Betelgeuse goes supernova, it's going to be bright. You're going to be able to see it in broad daylight. It's going to be brighter than the full moon. it won't harm anything on the Earth, thankfully. Up to about 40 or 50 light years away, you'd need to have something that kind of distance really kicking off to give us any serious issues in terms of radiation effects or whatever. But you look at gamma ray bursts, you look at the superluminal jets that are coming out of galaxies like M87, and you think, it's just incredible. I love this. This is what I love about astronomy. There's even if you're not out observing with binoculars or a telescope, whatever, every night, just being able to follow what's happening. If you're into the launch side of things, if you're into low Earth orbit, if you're into what SpaceX are doing, or if you're into the deepest and farthest objects in the universe, that's the beauty of astronomy. That's why they say that kids always love dinosaurs and astronomy, and it's true in space. It's so true.
Right, I'll let you lead off and look up.
Another great story. Yeah. So in terms of what have we got to see, I've been watching Venus now for quite some time. It's beautiful. It's just so stunning. You can't miss it. It's basically the brightest thing out there, apart from the sun and the moon at the moment. Obviously, a few months ago, we had a fantastic alignment where we had Jupiter, Saturn, Venus all kind of in the night sky. Now Venus is really putting on a heck of a show. And it's great. Even in a modest-sized telescope, you can see the fact that it isn't just a blob. It's not just a star, as it were. You can see the phases of this, even with a modest telescope. And it's great to watch those. As it's going around, obviously, it's closer into the sun than us. It's 30-odd million miles closer to the sun than us. An absolute hellish world, completely covered in cloud, acid rain, 400 degrees surface temperature, can melt lead. The only things that have ever successfully landed there, the Russian Venera spacecraft, which basically lasted not very long at all, and then got melted and crushed out of all existence because the surface pressure is also absolutely astronomical. So it's a shame because it's one of those things that everybody focuses on Mars and the potential for life on Mars and methane and all of the other things that are dragging us towards Mars as a exploration point. There's so much that we could learn from Venus in terms of what's happening on Earth, in terms of runaway climate change, etc. And the recent discovery of active volcanoes on the surface of Venus, again, makes it even more interesting. So keeping an eye on Venus, if you've got a half-decent telescope, taking images of it and using specialized filters, infrared filters, UV filters, you'll get to see some of the structure in the clouds. And I've imaged it with a calcium K-line filter, just with a relatively small refractor from the back garden some years ago, and you can see detail in the clouds. If you image with an infrared filter, you can actually see the surface because basically it's punching through and you're seeing the heat generated from the surfaces. Again, I've seen lots of amateur images of this. So Venus is absolutely wonderful to see at the moment. You can't miss it. Get out there with a pair of binoculars or a telescope. Obviously be careful. Wait until the sun's dropped below the horizon before you try picking out if you're going to be looking for any kind of magnification, any instrument that gives you magnification. Definitely one to look out for. The other one I know you're a big fan of, Tim, we talked about this last year, is Noctilucent Clouds. The NLC season is almost upon us. That's one to look out for.
Yeah, indeed. There have been one or two reports that think they've seen very faint ones. These are amazing. One of the few benefits of being at this latitude and in the summer when the sky doesn't get dark in the middle of the night is that we get to see these noctilucent clouds. And the clouds are normally the bane of an astronomer unless you're a radio astronomer or up in space. But these ones are beautiful, and you see them in what can otherwise be a more or less clear sky. They are caused by ice crystals forming on very, very high up dust right up in the mesosphere. About roughly 80 kilometers or so up. And we think they're particles of meteoric dust that attract, in certain conditions, which happen at this time of year, ice crystals to form on them. And that gives you then this reflection of the sunlight. And noctilucent means night shining. You only see them when the sun is so far below the horizon that it's late twilight and the sun will not be shining on any lower altitude clouds that we get normally in our troposphere. So they form beautiful patterns, silvery, ethereal, ghostly, wispy patterns. If you can record them with video, you will see that they move, that the structure changes, and so on. You need a good, clear horizon looking down almost to the northern horizon. Better when there's no moon. The moon is brightening at the moment, but it's still not too bad. After the moon is past full, definitely look out for them. And they're beautiful. They're easy to photograph because you have a moderately bright sky and then these even brighter silvery wispy clouds absolutely beautiful when you see them properly. One thing to look out for at this time of year is Capella. Depending on your latitude, of course, Capella can be just above the northern horizon, and you quite often see it, one of the bright stars in the sky, shining in the midst of these noctilucent clouds. Not spectacularly important in terms of astrophysics. It's literally just a local phenomenon in our atmosphere, but very well worth seeing. And they are an indication that the tiny little meteors that burn up in our upper atmosphere leave these tiny little dust particles behind, and they act as condensation points for the ice crystals.
Absolutely, and you don't need fancy equipment
No.
to do it. I mean, I've taken out a very simple SLR camera a few years ago. Basic tripod, cost about $5 from a car boot sale. Took that out, put it in the back garden, set a timer on it, and just basically let it go for several hours. And as you said, you can see the structure moving. Now with modern smartphones, new iPhones, and some of the top of the range Samsungs and various other phones that are out on the market, other phones are available. You've got this very good low light sensitivity. You've got very good time lapse capability. You can literally set up a smartphone on basically do it on a tripod, get it on a stand, take 1 or 2 second exposures. You will see these things when they're visible. They're really visible. It's like some of the auroral displays, and again, that's something else to keep an eye out for, because we've had some spectacular auroral displays into some big sunspot regions at the moment. There's a lot of solar activity, so well worth keeping an eye out if you've got the ability to have a look at the sun safely with the right equipment, going to local astronomy societies, hanging out at star parties, whatever. Basically talking to astronomers will love nothing more than to let you have a look through their telescope and show you what's happening in the night sky. And that kind of leads on to the last one, this supernova. If you've never seen an exploded star in another galaxy before, go and check out, search up your local astronomy society if you can, and just find out when they're meeting up next, because a lot of them take a big break between kind of March, September, because it's it's so bright, it's very, very difficult. But places like the Kielder Observatory up in Northumberland, they do fantastic public outreach events all through the summer. They do NLC watches, they do aurora watches, they do all sorts of things. They're going to be red hot on things like this. So Northumberland's one. You've got places like the Norman Lockyer Observatory down in Exeter in the southwest of England. I know in Ireland, Terry, you've got Armagh up in Northern Ireland that do a fantastic job on outreach. You've got Dunsink near Dublin as well. So there's lots around the country. I know Space Park Leicester do public outreach events. The Harwell Oxford Space Cluster, STFC, they do a lot of public outreach events. So if you've never seen an exploded star, go out. You don't have to buy a fancy telescope. You can just borrow somebody else's. Or there's online observatories like SLU and iTelescope and various others. If you want to have a go, just get some time on one of those. If you're involved in schools, there's free resources like the Fox telescope. You can do spectacular imaging with Hubble-sized instruments with that. So loads and loads to see.
Just one thing I should mention, noctilucent clouds aren't there all the time, and they are not predictable. No. You just basically have to go out, if it's a clear night, around local midnight, have a look, and if you see them, you'll have a beautiful sight. One other little thing that I'd forgotten about, Mars is actually just about to pass through the Beehive cluster M44 on the 2nd of June. Again, just a nice little sight. Mars will be a lot brighter. It's pretty faint at the moment compared with normal, but it'll be a lot brighter than the stars in the cluster. But nevertheless, particularly with a pair of binoculars or a wide field telescope, ruddy Mars passing through this lovely star cluster, 2nd of June. Hope it's clear.
Absolutely. And that's us for another month. So going to hand you back to our fantastic friends at Space Store, who are amazing in terms of the support. Always have been, always hopefully will be. Great bunch. Get yourselves down to Oxford. As I said, Harwell Space Cluster in Oxford, but in Oxford as well, in the city centre of one of the most beautiful cities in the entire UK. And if you're a Harry Potter fan, you've got some of the sets for Harry Potter there as well. So definitely get yourselves down to Space Store. Check out what they're doing in the covered market there, which is right in the centre of town. You can't miss it. Absolutely fantastic. And I'll hand you back to them.
Definitely. Thank you so much, Nick and Terry. Thanks again for another great show. And thanks also to our very engaged audience. Thank you, Chris. Yeah. Thank you, Mike. Thank you, Christian, as well, for tuning in tonight. Please subscribe to the channel if you haven't already. Also, join into our mailing list to make sure you're up to date with all of our latest offers and news and events. And yeah, as Nick said, we're open in Oxford every day in the covered market, a lovely place we're in now. come around. We've got some really, really interesting neighbors as well. Like it's just some crazy shops that've been there for like over 100 years. So we're a nice addition to the local community of the covered market, which is really nice. So yeah, do pop down, say hi. I'm personally there myself every Thursday and Friday. So do come and say hi. We've got some nice VR experiences for you to try on. Also serving coffee after your
And it's
VR
great
experience.
coffee. It's great coffee. It really is. You can get Latch's autograph. Go on a Thursday and Friday. Get
I'm not sure anyone wants that at the moment.
TV star. But there you go. Cool.
But yeah. Thank you, Nick and Terry. We can't do this without you. And spending your evenings with us once a month. It means a lot, and we're keeping everyone up to date with what's going on. Lovely to hear your views and opinions. And I mean, I definitely really enjoy the look-up section because it's just the perfect place to find the great best updates.
What's going on?
Yeah,
you take care, everyone. Enjoy the nights, guys. Enjoy the summer. We'll see you
27th of June. Hopefully, we'll be back.
We will.
Okay. Bye.
Bye.
Bye. Okay, guys.
There's only been about 20 or so recorded falls in British history. So to get one at all is quite rare. To get one that's witnessed is incredibly rare, and then recovered, I mean, this is off the scale rare. It makes it even more interesting in that the meteorite is what's called a carbonaceous chondrite. So these are some of the most primitive materials in the entire universe.